Alright, welcome back to Mr. P Helps with Algebra 2. This is Unit 1, Type 2 SLT number 11. We're solving simple radical equations. So your answer should contain only positive exponents. So in this case, we are going to use our laws of exponents. We're going to multiply coefficient times coefficient. So 2 times 2 is 4. N is the same thing as n to the first power. So when you are multiplying things with the same base, you add the exponents. 1 plus negative 4 makes negative 3. Once again, coefficient, 4 times 2 is 8. There is no x's over here, so no x's plus 1x over here makes 1. And 2y's plus 3 more y's makes 5y's, and that's your answer. Alright, so this time you have a coefficient raised to that power. So that means the coefficient has to be actually raised to that power. So 4 to the 4th power. 4 times 4 is 16, times 4 again is 64, times 4 again is 256. And then, anytime you have a base, so the base stays the same, with an exponent raised to another exponent, you multiply the exponents, which is the reason why it's 8. Alright, so once again, that's a coefficient. So the number in front has to be raised to the 3rd power. 3 times 3 is 9, times 3 is 27. X becomes x to the negative 6 because it's power to a power. Power to a power, you multiply the powers. And then y to the negative 12. Alright, over here, so 2 times 1 is 2, and add the exponents because it's multiplying things with the same base, so that's negative 8. This one, 2 times 3 makes 6, x to the negative 1st because negative 4 plus 3 makes negative 1, and y's disappear because 4 plus negative 4 makes 0. Now, it does say it can't contain any negative exponents in your answer, so I'm going to turn that negative exponent into a positive exponent by flipping it to the bottom. Same thing goes for over here. So 27 times, okay, x to the 6th goes on bottom, and y to the 12th goes on bottom, so that's your final answer. And if I was going to change this one, okay, the 4 stays on top, and the n to the negative 3rd becomes n to the positive 3rd by putting it on the bottom. Alright, so this one, so we're going to multiply. Power times power becomes n to the negative 3rd. Change that to a positive exponent, it's going to be that. And let's see, 4 to the negative 2nd. So everything in here has to be done to the negative 2nd. So that means I'm going to flip it to the bottom. It becomes 4 to the positive 2nd, which is 4 times 4 is 16. X to the negative 2nd, so the x becomes to the 2nd on the bottom because 1 times negative 2 is negative 2. Flip it to the bottom, make it positive. And y was already negative 2, so negative 2 times negative 2 is positive 4, so it stays on top. Alright, so once again, we are solving for radical expressions. So I want to change what's in radical form into rational form. So rational form means using it with a normal exponent, with a number, with a rational number, whether it be a fraction or an integer. We don't want a radical sign. So in this case, when you're changing radical to rational, the power of the base becomes the numerator, and the index of the radical becomes the denominator. So this becomes x to the 6/4. And the entire thing, so I put this in parentheses, is to the 3rd power, which is the same thing as the 1/3. Because all of this is to the 1st, that's 1/3. Now, power to a power, you multiply the power, so that gives me x to the 6/12. 6 times 1 is 6, 4 times 3 is 12. Alright, so for this one, x to the 5, that's the square root of x to the 5th, becomes x to the 5 seconds. And the reason why it's 5 seconds is because square root is to the 2nd power, you know, so it's square root of, so what times itself twice, so that's 5 seconds. Alright, this one's going to be 1 over x to the 1/5, and it's 1/5 because this is 1/5. This one's going to be, let's see, square root of x, so that's x to the 1/2 inside of parentheses with the 5 on the outside. So that 5 times 1/2 becomes 5 halves. Alright, so this one, y to the 1/4 to the negative 1/2. So we multiply power times a power, so 1 times negative 1 is negative 1, so y to the negative 1, 4 times 2 is 8, so negative 1/8. So we want to make that into radical form now. So first thing I'm going to do is I'm going to flip it because it's a negative. Y to the 1/8 on bottom. Now I want to change this to radical form, so that's the square, so let's see, y to the 1/8. So 1 becomes the power, and 8 becomes the index. All right, so x to the 3 seconds is x to the 3 seconds. So 2 becomes the index, and 3 is the power of the x. So in this one, we need to subtract. So they're already like bases. 7/5 minus 2/5. This is division. Things with the same base, whenever there's division, you subtract the exponent. 7/5 minus 2/5 is 5/5. Well, 5/5 is really just 1. And that was it. So in this one, we've got power, so we're multiplying things with the same base, so you're going to add the exponent. So 3 plus -4 makes -1. So I simplified the top first, and then I can divide these. -1, so you subtract when it's division. -1 minus 1 more makes -2. So that becomes x to the -2nd to the 2/3. Next thing I would do is my power to a power. -2 times 2/3 is -4/3. And then the last thing I would do is I would flip that so it becomes a positive exponent. And then last but not least, I want to change it to radical form. I know there's a lot of steps here going on, so that's 1 over x to the 4th and 3rd root. All right, quite a lot going on in that question. All right, so this is a to the 1/3 power, and then you're raising that to the square root, and the square root, as we already know from before, is the 1/2 power. 1/3 times 1/2 means a to the 1/6. All right, so this is b to the 1. I have a hard time seeing. I guess that's a 3 right there. So that's b to the 1/3. And it's all raised to the 4th root, which would be the 1/4, because all of this is to the first power, 1/4. 1/3 times 1/4 makes 1/12. All right, this one. So we've got our 5 on top. So a to the 1/5 on bottom. And these are not the same bases, so there's nothing you can do at that point. In 6 over a to the 2/3, and we're done. Okay, so I am going to, so we got a couple more questions here on the back, and then we'll get to the homework. So x to the 2nd to the 1/3, so that's power to a power, you multiply them. 2 times 1/3 makes 2/3. X to the 2/3, and that's in rational form, no radical. X to the 3/7 to the 2nd, that's power to a power. Once again, you multiply, so 2 times 3 makes 6, x to the 6/7. This one, simplify the top, it's going to become x to the 8th, because you add the exponents. The bottom becomes x to the 2nd, add the exponents. Once you've done that, you can then divide. 8 minus 2 makes 6, so it's 8 to the 6th to the 4th, so then you multiply, power to a power becomes x to the 24th. For this one, simplify again. So this makes x to the 7th. This makes x to the 6th. 7 minus 6 makes 1. So all of this on the inside just represents just x to the 1/4. So this is x to the 1/4. All right, so inside here you got 9 plus 6 makes 15. On the bottom you got 6. 15 minus 6 makes 9. So everything on the inside becomes x to the 9th. After you add up here and add up here, and then subtract your two answers, and then it becomes 1/2 on the outside. Power to a power, you multiply, so x to the 9/2. And 9 divided by 2 is the same as 4.5. All right, last one. So this is 7, this is 4. 7 minus 4 is 3, so that's x to the 3rd to the 1/5, and then simplify by multiplying. 3 times 1/5 is 3/5. And there's your answer, which would be the same thing in radical form. Sorry, these are all supposed to be in radical form. So that's x to the 3rd to the 5th root. This one, x to the 9/2, is x to the 9th to the 2nd power, which I didn't really need to put that 2 there. X to the 1/4 is x to the 1st to the 4th root. If the answer was x to the 24th, so that's x to the 24 over 1 in this case. Okay, so you know what? I could... In this case, I could put x to the 48th square root. I just multiplied this by 2 to make this. Because x to the 24 times x to the 24th times itself equals this. X to the 6/7 would be x to the 6/7. And x to the 2/5 is x to the 2/3. Sorry, x to the 2nd to the 3rd root of. All right, so now getting to the homework. All right, so it looks like we're solving equations. So when I'm solving equations, I'm going to solve it just like I would solve any other equation. I'm going to get rid of the radical sign. There's nothing on the outside. Always look on the outside first. If there's nothing on the outside, then you can get rid of the radical. Then and only then can you get rid of what's on the inside of the radical. So I'm going to square both sides. And the reason I'm doing that is because the opposite of radical is square. They're inverses of each other, so they cancel each other out. So the square root of x squared is x. 9 squared is 81, and then I need to double check because there could be an answer that does not make sense, and it's not really an actual answer. So I'm going to plug this number back in. So if x square root of 81 actually 9, it sure is, so that's not an extraneous answer. So had this not made sense, then it would be extraneous, which means it's not really an actual answer. Because the square root of a number can never be a negative. So that's the reason why when you solved it, it might not have worked. So if I add 1 to both sides here, so that gives me the square root of x is equal to -3. Now, just like I had said before, the square root of any number can never be a negative. So this is going to be an extraneous solution. EOUS. Okay, so I would have solved it and got x equals 9. But I want to show you, so when I take 9 and plug it back in, the square root of 9 is 3, and 3 minus 1 is not -4. So that's not true. Since it's not true, that means that that answer is extraneous. Alright, so subtract 15 from both sides on here. That's going to leave you with 7 equals the square root of x, square both sides, and x equals 49. Over here, so subtract 3 from both sides, and that gives you the opposite of the square root of x equals 2. We got that opposite out there. So that's really like a -1 being multiplied. So I'm going to do the opposite, which is divide both sides by -1. So that means the square root of x is equal to -2. And I already now know that this answer is going to be extraneous. And the reason I know this is because the square root of a number can never be a negative. So there's no reason for me to go on at that point. Alright, thanks again for watching. Please give it a like to help you learn how to either evaluate expressions or solve equations with radical signs and changing radical to rational expressions. Okay, thanks again for watching. Have a